Hello guys, welcome back. In this video, I'll explain how to implement document based question and answering using Pinecone, or how to implement document based question and answering using a RAG approach. In the RAG approach, what happens is we have retriever and generator. Based on the arguments or question that we provide, retriever will retrieve a specific content from the document and then generator will generate. I'll explain that. So let's say I have a document. Now, in this RAG approach, what you will do is first we will generate vectors related to this document and then we will store it somewhere. We will store it somewhere. Now, for this case, we are using Pinecone as a vector store. Other than Pinecone, we have multiple platforms available as well as we have other vector store also available. But for now, we are using Pinecone since it providing us a cloud-based platform to store our vectors with less cost, even free right now. That is up to 2 GB. We can able to store vector vectors. So that's why we are using now this Pinecone. I'll show you how to do or how to create from end to end, like how to use this Pinecone as a vector store. Then after what we will do. So initially we'll create vectors from our document and store them in this Pinecone. But what we actually require for our question, we want the similar or we want the answers from our document. So initially we have stored the vectors related to our document. Then next what we will do is we'll again ask the question or we'll take the question and we'll pass the or we'll convert this question into embeddings. Then we will perform cosine similarity by using this Pinecone. So whenever you perform cosine similarity, for this particular question and answer related embeddings or vectors, related nearest vectors which are present in this document. Already it contains the document related vectors, right? Yes. So among that vector related documents, what are the nearest vectors related to this document are present for this question and answering related vector? Those will be sent out as a result. Like we can able to get top 3 or top 5, like that we can able to get top top documents or top contents. In the document we have multiple contents or paragraphs, so top contents which are related to this question will come out. Then what we will do is we'll again pass that to specific model or any one of the model, and we will get a human understandable response from that model. So for this demo, I am using a Hugging Face model, any one of the Hugging Face model, to get the response in a human understandable format. That is, so I'll explain you once again what happens during the process of RAG. First, this is the retriever. Pinecone is the retriever we are using, where here cosine similarity is the function which is happening. Initially, here we will store our document related vectors. So whenever the question related vectors will come, the cosine similarity will happen in it, and document related contents will be, that is top similar document related contents to this question will be filtered out and it will provide as a response. So now it will provide as the response related to our question. So in order to get this response in a human readable format or conversational format or more conversational or more understanding format, we will pass this response as well as question to our model. This model will act as a generator. It will generate finally the response. It will act as a retriever and it will act as a generator. This will generate the augments and this will generate the response. So this is what the approach or happens in a RAG based models. Before implementing this, I want to explain once again like what are the steps involved. So initially what we need to do, we need to convert this document into vectors. That is, from this document we need to generate the vectors and we need to store the vectors in this Pinecone. Then this Pinecone acts as a vector store. In order to store our vectors, this acts as a vector store or cloud based vector store. Then after we need to generate vectors for our question and we need to pass it to or we need to query this vector store by using our question so that this vector store will generate similar content in the document, similar content related to the question present in the document. That content it will generate like top how many contents we want, those many contents this will generate. After that we will send a query to our model by passing this similar content as well as our question so that this will generate us the response in a human understandable format. Now the important points or the important terminologies that we need to remember here is this acts as a generator. This model acts as a generator. So not only Hugging Face model, what are the model that you use, it acts as a generator where it will generate a human understandable or a human conversational content other than document content directly based on the question that we provide and the similar content this model will get. Then how it will access, it acts as a retriever. In RAG implementation it acts as a retriever where it will generate the augments or similar content based on the question that we provide, question related vectors that we query with this vector store. Even this acts as a vector store. Why we can say this Pinecone acts as a vector store? The reason is that we are storing our document related vectors inside this Pinecone. So before storing the vectors inside this Pinecone, we need to create some index. I'll show you this end-to-end implementation. First one, let's perform generating the vectors for our document content. And one more question I want to ask here. So how we are using Pinecone? We are using Pinecone as a vector store to store the vectors. And at final, what is generating our response? The generator will generate our response. The model that we are using to generate the response based on the similar content as well as the question is nothing but our generator, that is nothing but will generate our response. Now let's have a question like what is retriever? This retriever is nothing but it is also a model. It is also a model. Then how this model is used? This model we are using for generating the vectors or yes, for generating the vectors we are using this model. This is again a model only, not Pinecone. This retriever is again a model only for generating the vectors related to a document or question. For the document related content, I'm just taking some AI generated response related to RAG. So you can see I'm just copying this content. I'm just copying this. Further, I'll use it as a document content. Now I'm opening a notebook, Google Colab notebook. Here, first I'll do everything like step by step, everything related to our task. So first, let's store the document related content. Let's say my document related content is nothing but the content that I have copied. I'm pasting that here. So this is related to, let's say, my document content. In real time, we might have a large content, right? Yes. So we need some vector store. We need some vector store to store all the document content related vectors. For now, I'm using this Pinecone. This is my Pinecone account. You can see here. So actually there is already one index is present in my default database. For now, we'll create one more index. So index you can assume it as a box or storage or container where you can able to store your vectors like database. You can assume this index as nothing but some database to store your content. So in order to store our vectors, we need to create one index, and inside that index we need to store our vectors. Let's have a question. Why do I choose this Pinecone as my vector store currently? The reason is that you can see the storage limits. These all are free tier storage limits. I have 2 GB of free storage and read capacity like 1 million requests that I can able to send per month, and 2 million requests that I can able to send for writing per month. And if you want like for enterprise level, if you want to increase the limit, then you can upgrade like per month. You can able to upgrade and get more read and write capacity units as well as storage. You can see for storage per month it will charge that is per GB it will be charging 0.33. That is how much you use, that much only you will pay like that. Then like for write capacity units, if you want more than 2 million writes, then you need to upgrade for standard or enterprise related. Then so that particular related limits will be came to you so that you can able to use it. Currently this Pinecone vector store acts as a cloud storage for us to store our document content related vectors. Okay, let's move back. So this is my document content. Let's say this is my document content. Now what I am expecting to do. Initially, I need to generate some embeddings for this document content. Initially, we need to generate embeddings for that. So, or vectors for that. So, how to generate these vectors? By using some retriever, we need to generate this document related vectors. So, for this, since this is a sentence related relation, I want to use sentence transformers because sentence transformers are well designed to provide high performance, or sentence transformers are basically designed to create embeddings or vectors for whole sentence that we provide to that particular model or sentence transformer. I'll open that sentence transformer models. Let's take the advanced, or you can say high performance or over performing model. Here we have pre-trained models are available, and since we are performing for sentence embeddings or semantic search, for semantic search The average performance we can able to see, and the speed as well as the model size you can able to see. Let's concentrate on the performance, like how much good it is performing. Based on that, let's select a model. So 63 among all these, you can see this is the best performing model. Let's take this model card and let's copy this model name, and let's check for Hugging Face. You can see Hugging Face model. In Hugging Face, this model is already available, right? Yes. So we can able to utilize from there. Since this model is present in Hugging Face, if I want to use this, then simply we need to import transformers, and then so this is one way to use this. Since we are generating embeddings, we need this tokenizer. Or we can even move on with LangChain to use this Hugging Face model, to connect to this Hugging Face model. Or even we have one more approach, that is we can directly use sentence transformer. That is we can install the sentence transformer and we can use it. You can see from sentence transformer we can able to import a sentence transformer and specify the model, and then you can able to use that to generate the embeddings for that this particular model. So let's see this approach, like using the sentence transformer to generate the embeddings or vectors related to the content. Now let's see the process, or let's implement this installation. First I want to install this. You can see the command. So this is the command that we'll use, pip install -u sentence transformer, and you can see I'm providing that here by providing a hyphen, by providing not. If not installed, then please install it so that it will be gets installed. Right now it is getting installing into my notebook. Let's say I don't want this all, like this all installation thing or notes, then you can simply provide here hyphen hyphen quit and simply press on shift and enter, so that it will do not show you this all thing. But let's continue, or let's finish this process, then after we'll try it once more again, so that you would not see any more steps or this much content related to what is happening or how it is installing. Yeah, successfully all the requirements I think gets installed. So these all NVIDIA related things was installed, and let's also verify like the sentence transformer is there or not. Yeah, you can see sentence transformer is already there. You can simply use this quit command and shift enter, so that you will not get like that much of explanation or installation things. Okay, now we have the sentence transformer. You can use that sentence transformer to perform your task. From sentence transformer, let's import this sentence transformer. Now we need to initialize our model by using this sentence transformer, and we need to paste the model, like what are the model that we have previously expecting to use. We are expecting to use the high performance model, that is this. I'm just copying this name and providing this there, and let's try to encode, or let's try to load this model. Okay, now this model is getting loading. Right now, this cell working was completed. That means our model was loaded successfully. You can print the model so that you can see the model related details like max sequence limit it will take, and you can use the model to encode or generate the embeddings. Encode of, so what is our document content? This is the right. Let's provide at a time our document content, and let's try to see whether it can able to generate or not. Okay, now it can able to generate, but actually the issue was that, so in your document not only this, you have multiple or you have a large content, right? Yes. So two times larger than this or even 10 times larger than this content will be there. So during that time what happens is it cannot able to generate, the model cannot able to generate. So not only 10 times, let's say it will be like 100 times larger than this. So it was generating. Let's see like 100 times this, what it will show us. The same content is showing, but so 100 times means it need to be replicated 100 times. Let's manually create this document content or modify this document content to increase like how many times we want those many times. Let's say 10 times I want to iterate this function, and 10 times for this document content I want to add the document content just to increase the content, and at the end I want to print this document content. In Colab you can directly write that variable name so that it will show you or it will print you that content. You can just expand it. Yeah, you can see for 10 times it was replicated right now. Or let's comment this. Let's rerun this so that now the document content will be just only once. So till here only the document content. If we type 10 times, multiply it by using 10, so then again it's replicating. Okay. Okay, now I want to explain one thing, that is this. You can see the max sequence length. The max sequence length must be less than or equal to this. If it exceeds, then it won't generate the response. This model won't generate the response. So we need to adjust our model to take only up to the dimensions or the sequence length or the size of expecting content. So that does not exceed. If it exceeds, then what happens is this model won't able to generate the response. And this dimension is nothing but, also one more important point, this dimension is also very important if we consider our vector store. Here you can able to observe the dimension. This dimension actually used by our Pinecone or vector store to store the embeddings. If we are storing a vector that is having other dimension than we specified for our index, then this index present in our vector store does not store what are the vectors that we are trying to store inside it. So we need to generate our vectors only specific to this index, specific to the same similar size of this index. So, okay, let's generate the embeddings for this document content at first. Embeddings are vectors. for this document content. How do I will get it? Model dot encode is a simple approach. Then you shift and enter so that this vectors will be generated and stores in this vectors variable. Now what I want to do, I want to put these vectors inside my vector store. So what is my vector store? Vector store is nothing but my Pinecone. So in order to put my content or vectors into this vector store, first I need to create an index. Then how to create that index, sir? I want to show you two ways to create that index. First one is just click on this and provide your name like demo index 1 cannot contain lowercase. Okay, underscores are not allowed, and you can just provide the details like what is the dimension. This dimension you need to provide based on the model that you are using. Currently, which model I am using? I am using this pre-trained transformer model, that is all MPNet base V2. So you just copy this dimension and paste the same dimension there so that your model generating vectors dimension need to be matched with the storage dimension. So that's why you need to provide the same. And simply that's it. You just click on create index so that it will create an index for you from here. I'm just showing you. I'm just clicking on create index. So this is how from console you can able to create the index. Then you can able to store the vectors inside it. Now I don't want to create my index from console. I want to delete it. I want to create my index from programmatically. So that also I'll show you. I just deleting this. So this being deleting. Yeah, done. I'll show you the way how to create that index from code as well. If you want to create an index or if you want to authenticate, so before creating an index you must need to authenticate with that Pinecone, then only you can able to create an index. If you want to create an index or authenticate with Pinecone, you first need to import this Pinecone. You can see Pinecone is not actually present, so let's install this. If not there, pip install this Pinecone in a white mode. Now let's try to import the Pinecone. So still what we're getting some error like pine. Okay, Pine, not Pin. Now the installation is getting started. Yeah, it's done. Now let's rerun this whether we can able to import it or not. Okay, we have done, like we have installed the Pinecone. So that's why we can able to import this Pinecone correctly. Now we successfully downloaded this Pinecone. I want to I want to create an index inside my database. So in order to create a index inside our database, we first need to authenticate to this Pinecone. How to authenticate to this Pinecone, sir? So first from Pinecone you need to import this Pinecone. Then so by using this Pinecone, you need to provide some. You can see API key here, API underscore key. So how to get this API key? I already have a Pinecone account. If you do not have, just create one Pinecone account, and so just click on your name. Then you can see here API keys. You just click on it. I've already created one index or API key. So for you, just click on this create API key and provide some name, and then click on create key so that it will create a key and show you an option to copy. So you just copy that key and you can use it. Once you close that pop-up, that is the key pop up, then you won't able to again copy that key. So that's why I'm specifying you like copy the key at that moment whenever it was generated. I have generated my key previously itself. Now I'm storing my key inside this secrets. So not to show you, that's why I'm storing that secret here. So what is this? It's a pine cone, or it's a best practice to hide it or store it somewhere in secrets. Pinecone API key. So and here I'm just pasting or saving that API key here. Now I want to provide access to this, like to this notebook. I want to provide access to this key. So that's why I enable this. I'm just copying this, and so I want to access this key. So for this, just before to this tab, I want to import this like user secrets from Google Colab. I want to import this user data, and by using that user data dot get, so I'm providing my secret name, that is this Pinecone API key, to get this Pinecone, or you can say API key of my Pinecone. Then I want to use that API key here. So I'm just clicking on shift and enter so that it will get the API key, and I'm using that API key here and storing that connection as PC. So now my Pinecone connection was established. I want to create an index by using this Pinecone connection. So let's close this. Yeah. So I want to create an index programmatically from here. If you want to create an index, then you can use the command like, so by using the Pinecone connection PC dot, since it's a new index, I want to write like a create. You can see create index option is already there. So inside that you need to provide the name of your index. So let's take the, or let's store the index name globally so that we can able to use it so whenever we require. I want to use this index name like doc store or vector store, or let's take index 1. So that's enough. Then you need to provide that index name here. Then after we need to specify the dimension here. So what is the dimension? Like, so what dimension related vectors we are expecting to store, that we need to specify. If we open our model, or what are the model that we are using to generate the embeddings, here it will generate the dimension like 768. So that's why I'm providing there the same. Then we need to specify the matrix. So by using what matrix you want to perform the cosine similar, or by using what matrix you want to perform mm, similarity search. By using cosine similarity, I want to perform this similarity search. So that's why I'm providing cosine. I- In Pinecone, we have other approaches or other similarity based searches as well. So whenever we are creating an index inside our database, it will show you the other ways as well. You can see the matrices. Cosine matrix is there, Euclidean matrix is there, dot product matrix is there. Based on any one of the matrix, you can able to generate the embeddings. For now, I'm using the cosine matrix, so that's why I'm providing this as the cosine. Okay. By default, you can able to you need to specify the specifications. So what does the specifications tells? These will tell like on top of what location, in which cloud you are storing your data. Currently, I'm storing my data in AWS region like US East 1. So these are the default specifications. In order to specify this, we need to import this. That is a serverless specification. From where we need to import this is from Pinecone only. We need to import this serverless specifications, and we are creating this pc dot create index of matrix. It's not matrix, it's a metric. So still we are getting error like invalid API key. So whatever the API key that we provided, that's an invalid. Now I just changed my API key, so I want to load it again. Now let's see whether the pinecone index will be created or not. You can see how pinecone index was created right now. That is visible here. And you can open the browser like Pinecone index, and you just open your database. So currently one index is showing. Just reload the page so that a newly created index also visible to you. Yes, you can able to observe that whatever the index that we created, that is visible to me right now here. I'm just opening it. So inside this, we need to actually store our vectors. Like we need to store it in some namespace. Inside some namespace, we need to store our vectors. Currently you can see there is a default namespace but zero records are present. Eh, here, yeah, there is a no records are there. Now we need to store our records, or you can say content. Now if you want, you have already created an index, and if you want, or if you are expecting to store the document related content, what are the document related vectors that you created, that if you want to store inside your vector database, first we need to connect to our index. What are the index that we created, we need to connect to it. So how to connect to that index and store that connection? I'm storing the connection in this index variable, and I'm connecting it by using pc dot index of pc is nothing but the pinecone connection that we previously initialized. And by using that connection, I'm connecting to my, so what is your nothing but, so what is your index is nothing but the index one that I have previously created. Then you need to specify the host, like where it was hosted, that hosted id you need to provide. You can see that hosted index was visible here, or you can just copy it from your pinecone. You can see this is the hosted index. I'm just copying it and pasting that there. So just clicking on enter. Now we got connected to our index as well. Then inside that index, by using some namespace, I want to store those vectors of our document. To store your vectors in your index, then you need to use the command like index.upsert. This is a command that you use. So inside this, you can see a vectors. So what vectors you want to store, that vectors you need to provide in the form of a list of vectors. You can see here clearly the list of vectors you need to provide, and namespace also you can able to provide, like namespace I'm providing at first. Let's say ns1 is the namespace that I'm using, and vectors. So how do I provide my vectors? We can able to provide our vectors as a list of vectors we need to provide, and we need to specify like what content we are storing, a list of what content we are storing, list of tuples we need to specify. So in the each tuple we need to specify two things. So one is what are the things that we are expecting to store. Like first, I need to store my document content. right? So for this document content, what is the vector which was or corresponding vector which was generated? That vector I want to store. So initially I want to store the vectors. Let's provide the vectors that was generated. So what is the name? Yeah, vectors only. Then these vectors are related to what content? That I am specifying within this, like the text of that is nothing but this doc content. I'm specifying this, and I want to provide the name like the content one. So these vectors are related to content one or related to document one, and the document content is this and the vectors is this. I'm using this index.offset command to store these vectors inside this document one within this ns1 namespace. I'm just clicking on shift and enter. You can see upsetted count, that is 1. So one document content is stored there. You can open this vector store index and just reload this page so that you can able to see the content inside it or whatever the content that you inserted into this. So you can see that like document 1 related content text is this, and you just click on edit so that it will show you the values of vectors that you stored on top of what namespace, on top of what document id, for what text you stored this. Those all data will be visible here. So okay, now this is related to one document content. In real time you might have multiple document contents are there. Let's take a document content 2, document content 2, and inside this let's say I have LLM, like, so what is LLM? Let's ask the question. Let's say I have multiple documents. So one document is related to RAG and one document is related to LLM related content. I'm just copying this content and storing this content in this doc2 variable and store the content again back in the same vector store in the same namespace with another document name. I'm just copying this and pasting that here. I want to store it as a doc2 vectors and document content 2. I haven't created these vectors, right? So let's create these vectors as well. So how do we actually create these vectors? We create these vectors by using the model that we are using, like model dot encode. Inside the model variable we have already loaded our model dot encode of. So what is the document content that we need to specify? Doc content 2, yes. And then okay, now our vectors will be generated related to our document content 2, and I'm just upsorting this data. So what happens? Doc content 2 is not defined. I think the name mistake. Okay, now this data also inserted. Like the second document content is also inserted. Now we have two documents related content which is stored in our vector store. So whenever we query our Pinecone related this document content or related to this index, then what happens is based on the question that we provide, that particular related document content will be visible to us. We have two document contents, that is two records are visible here, and among the two we will get only the required document content. Let's also see that querying, how to do that querying. Before querying, let's move back to the architecture to see what are the things that we have done. We have generated the document related content and stored document related vectors we have generated and stored the vectors in this vector store, that is Pinecone. Now we want to create a question and generate the vectors related to it and query this vector store. Okay, let's do it. So let's take a question. So what is the question? So first let's ask the question related to document one, like what is RAG? Like this, I have written some question. Now I want to generate some vectors for this question related vectors, right? Q underscore vectors, that is a question related vectors. Model dot encode. So this is nothing but our the same model that we used for generating the document related vectors. That is this all MP net base v2. Now we are generating the vectors for our question, so that's why I'm writing this question. Okay, now our question related vectors have been generated. We can even see that vectors, you can see, yes, I'm just clearing this. Okay, now, so we have our question related vectors are also available. Now we need to query our index, whatever the index that we previously created. So this is the index, right? We have already created the index and linked it with that index by using this index variable. I'm using the same index variable to query. So this is the query command we need to use, query, and the namespace also we need to specify. On top of what namespace your document contents are present. In ns1 my document related contents are present, so that's why I'm providing that. And vectors, like what is your question vectors, that you need to specify here in the form of a list, in the form of a list. So that's why you need to use to underscore to list is the command that you need to use. Then you need to specify like how many contents or how many references you want. By using top k, I want only one, like top one document I want related to my question. And then you need to include the values that you need to specify. Yes, that's true, so that's why I'm providing this. And you need to include the metadata or while getting, so that's also you need to specify. And then filters, if you want to provide, then you can provide that. So currently I do not have, so that's why I'm providing none. That's it. You just click on enter, shift and enter. So what happened? Bad request, vector or id must be provided. Let's see, like so what is the vector that we are sending to it, whether we are sending a single vector or a list of vectors. It's a single vector. So since we are sending a single vector, we need to specify it by using a 0, so that it will send a single vector other than 2D. Whereas if you are sending 2D vector, then we need to specify it like vector. Like here as well, we need to include like vector other than vectors. Still we are getting error. That means vector dimension 1 does not match with 768. Here we not specify 0. Like, so whenever we are specifying 0, it was taking only one dimension. You can see we got the response related to our query. So matching one document will be we are getting. So index.query. So what it will provide us? like matches it will provide us. So let's store that matches inside this, and let's get only the matches. Let's rerun it. Okay, so now you can able to print that matches, like these many matching documents will be you will get actually, like how many top k you will provide, those many matching documents you will get. So currently we want one, so that's why we get only one inside this matching documents also. So what do we want the expected text. You can see here we have multiple like score. Based on the matching, the scores also there, and values related to our vectors is there, and the text that we stored, that metadata is there, and as well as the document content id is also there. So among matches, let's take the result, or you can say, so what are the response, like top one similar, top one similar content. So let's take it from the matches. How do we take it? So matches of this metadata. Inside this metadata, so where it was inside the text it was. So I'm just copying this text and pasting that here. So let's run this, so that, okay, what we get, we getting some string slicing mistake. Let's see up to here whether it was done. No. Yeah, so let's print this top one similarity content, like how the content will be, so that we'll extract only the result. Basically it's a list of values, so matches of 0 will provide me the top one. So inside this top one we need to get, yes, we got the top one. Inside this we first need to pick this metadata. So inside this we need to pick this text, so that we will get the related context. Okay, now we can run this, so that we can able to get only the required. You can see the required similar content only now we got. If we move back to our architecture and see what are we done, we have, so first the document related vector storing is done. Then particularly related to our question, we even generated the similar content by using our vector store and retriever. So then what we need to do by using generator, we need to pass our generated content as well as the question and get the response, similar response, or human understandable conversational response. Since I told you that I'll use some Hugging Face model, I'll do the same thing. Like I want to use, so you can see Hugging Face API key is already available here. Okay, now I want to first connect to my Hugging Face to use any particular model. So if you want to connect or use any Hugging Face model by using LangChain, first you need to install that LangChain Hugging Face. I'm just installing the LangChain Hugging Face, and I don't want this all. So I'm again rerunning it. Then after, by using this LangChain Hugging Face, we need to connect it to our model by using the Hugging Face endpoint. So from LangChain Hugging Face, we need to import Hugging Face endpoint. Hugging Face endpoints we need to import. So we need to import this Hugging Face endpoint. So then after, what we'll do is we need to connect to specific model. Before connecting to specific model, you need to specify like Hugging Face token. So what is your Hugging Face token? Or let's connect to one of the model Hugging Face endpoint. So whatever the thing that we imported, I'm using that. And here I'm specifying my model name. So what is our model? Currently I want to use Mistral model from Hugging Face. I'm just opening this Hugging Face. For retriever, I'm using a different model. For interacting, I'm using a different model. Let's say I want to use a Mistral based model like the top one, that is Mistral-7B Instruct-v0.3. I'm just copying this model name and pasting the same here. And so the task is nothing but text generation. Okay, I want to connect to this at first, and I want to take it as a LLM1 to get the response from it. So I think it was connected. LLM1 dot invoke is a command that you need to use in order to invoke that LLM with some specific user prompt or message. Let's say I want to provide a messages. Like what are my messages? My messages are nothing but a list of human as well as a system or agent related messages. For this demo, I'm just providing the human message. Like for that particular question, for the question whatever I have, I need a response. I need a response from the content which was generated. That is this. So I need to provide my content, or provide me the response. Let's say this is my prompt. I want to put it. I want to put it in another variable. Since it's a multi-line, I'm using multi-line command. Provide me the response for the below question from the below document content. I want to provide my question. I'm using a F here to specify the question, like by using formatted strings. So what is my question inside what variable it was stored inside this questions variable? I'm just copying that. I'm providing that question here. And what is my document related content that we filtered by using this retriever augment generation? That is nothing but so this is the similar content that we fetch from our document, or the related document content is this. So I'm providing this. So this is the prompt that I'm saying, like question is this and the similar content is this. I need to invoke my model and get the response from it and just sending the request. You can see authentication error. The reason that we are getting is we haven't passed any API key or Hugging Face API token here. So that's why while authenticating with Hugging Face model, we are getting some error. We are providing the Hugging Face API token here, like Hugging Face API token. So I need to provide it before I'm creating a new code cell. Just move it a bit down so that okay. So here I want to provide like a Hugging Face API token, Hugging Face API token variable I want to specify here. So before this, I want to provide access to my API token. You can see for this notebook, I provided API token related access, and I need to get it and store it in this. For this from collab, dot or Google Colab. You need to import this user data, and by using this user data dot get method, you need to get this Hugging Face API key from here. I've provided access to this notebook, and then you can use that key here to create your LLM1, and you can use that to invoke your LLM. Now you can see you got the response. Let's read the response. RAG is known as Retrieval Augmented Reasoning. RAG is nothing but Retrieval Augmented Reasoning. Let's ask the question like a bit more elaborated way. So where is this question? Like what is the RAG? And explain it. And explain it. So we changed the question. Now we need to run this again like to get the top matching content. You can see the top matching content is this only, and we don't need to install it again. We just need to get the response from our, we need to invoke our model with the updated question with the updated content. You can see RAG is an AI framework that combines LLMs with, you can see some response we got like expanded response other than previous one. So based on our question, it will generate our the response. And like for now, we have two documents already stored in it. Like in our vector store, we have two documents stored. One is related to LLM and one is related to RAG. We have already questioned related to RAG. Now we will ask the question related to LLM. What is LLM? That question I want to ask to my vector store to see whether that particular related document content we are getting or not. You can see now the content is whatever the content that we get is related to our LLM, not related to our RAG. Now we will ask our model to get the response. So we are invoking our model with updated question and updated content. You can see what is LLM is the question. They are trained on a large data which allows them to learn complex language patterns and human and so on. So response we got. So this is the final human understandable response from our model. If we recap like whatever the things that we done, we have taken a question, or we first taken the document content. We first taken the document content and we taken some model from sentence transformer, and we just encoded that document content by using the model, and we created the vectors. Then we created some index in our vectors in our Pinecone. We stored our content inside that index in our vector store, that is Pinecone, and we have taken another document content and we created vectors for it, and we stored that content, that document related content vectors also inside the same vector store, that is Pinecone. Then we taken a question and we encoded or we created a vector for that question. We performed a query for that index where my documents related content is there. To that index we provided our query with the question whatever we generated, and we got the similar document contents. And after getting the similar contents, we are providing this content as well as our question to some LLM model and get the response, that is a relevant conversational response from that model, right? Yes. Or we can even modify the prompt to get simple response for our question based on the context that we provide. LLM stands for large language model, which enables it to learn and generate human like text. So that's a simple response related to the question. What is the question that we provided? What is LLM? Right? Yes. If we move back to the architecture, so From this demo, you understood the concepts like so how to implement RAG. This RAG is nothing but retriever will generate the augments, and that augments we are passing to our generator. This generator model will generate the final response. So what do we use as a vector store in this? Pinecone, we are using it as a vector store to store the multiple document related contents. We have stored two documents related contents in our Pinecone vector store in this video. Then we asked a question like what is LLM is the second question, and the first question is like what is a RAG, and we got the response like similar content documents we got, and we're passing our question as well as the document content to our model, and we're getting the final response from our model by implementing RAG. When do we use this approach? We use this approach whenever we have multiple documents and a lot of content. So during that time, we are unable to pass the document content directly to this model and get the response from our model. So during that time, we need to store all the documents related content in our Pinecone vector store, and by using the query, we need to get by using the cosine similarity, we need to get only the specific or related documents, and only inside that documents only out of available many documents, we are just picking only the similar documents, and we are sending only that particular document content to our model and getting the response from our model. So in this way we can able to get the appropriate content. You might have a question in your mind like so let's say if I do not have the content, or if I do not have the document related to the particular question, then what happens? Then what happens is so based on the query that you perform, it will provide you the response, or whatever the content that it will generate, based on that it will generate the response. Or let's try it. Like the question is we have RAG related question, and we have also LLM related question. Let's ask the DevOps related question. What is DevOps? So let's perform this, and let's see the top content. So it is providing me the response related to RAG. Okay, let's continue to ask the question to our LLM model and see what it will generate. So DevOps is a software approach that aims to train. So seems to be okay. The response is yes. I think that content might present in this. So that's why we're getting the response. Basically, what happens is particularly related to our question, if that was not matched with the content, it won't need to generate the document related content and we not get the response. So that's what happened in RAG based models. So during that time, what happens is related to our particular question only, we'll get the response. So this is how you can able to implement a RAG based approaches in your real time, and you can able to get the responses back. So this is all about this video. We have successfully used Pinecone as a vector store, and we implemented RAG based approach to perform document based question and answering. I hope you understood this video and you get some knowledge from this video like how to implement this RAG. And I hope this video is useful. If you feel this video is useful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye, guys.